Good afternoon, everyone. Let us start. Remember, we have been learning geometric processes. Yesterday, we learned about endogenic geometric processes, and now we shall discuss about exogenic processes. Now I will present my screen. Exogenic processes, meaning you have learned earlier. See the processes acting on the Earth's surface. Here, exogenic processes derive their energy from atmosphere, determined by the ultimate energy from the sun and also the gradients created by tectonic factors. So exogenic processes or forces are derived from this sun, the energy. Okay, the energy of the exogenic processes is derived from the sun, and because of differential heating of the earth on the earth surface, there may be pressure differences. Say for example, here this is the earth surface, and here in some area there may be bright sunshine, and in the other areas there may be this cloudiness, and because of that, there may be the intensity of the sunlight may be low, and here we get very bright sunshine, and that is why the earth surface will be heated, and because of that there may be formation of low pressure, and so it results in the pressure differences because of the differential heating on the earth surface. It creates pressure differences, and once there is a pressure difference, then wind blows from the high pressure areas to the low pressure areas. All these things, all these concepts you have learned earlier, and once we have got these pressure differences, then wind will blow from one place to another, and so the action of the exogenic processes start on the earth surface. And once the low pressure is formed over the earth surface, then there may be again formation of cloud, then there may be rainfall. Then if there is rainfall, then running water will be there. So the action of the exogenic processes starts because of this differential heating and cooling on the earth surface. That means the ultimate source of energy for the exogenic processes is the sun. If there were no sun, then no wind, no weather phenomena, no running water, no glacier, everything will not be there. So exogenic processes derive their energy from the sun as well as from the gradients, that is slopes created by the tectonic factors. So let us continue. Gravitational forces acts upon all the earth surface. See, gravitational force acts upon all earth's materials having a sloping surface and tend to produce movement of matter in downslope direction. And so regarding this also we have to call back the diagram. See here we have the slope, and we know that gravity pulls down all the objects downwards, and so this is the slope. Once we have got the slope here, then every object will be pulling downwards. That means because of gravity and because of the slope, all the particles, all the materials are moving downwards, and in this way the action of the exogenic processes starts. Okay, so let us learn some important terms. We have a term here, stress. So what is stress? So here, force applied per unit area is called stress. Okay, force applied per unit area is called stress. Per unit area means maybe say maybe a square centimeter. Okay, say for example this is an area, so this is an area, and the forces applied in this unit area is known as the stress. Okay, let us say this is 1 square centimeter, for example. Okay, here let us say this is 1 square centimeter. Just wait. And the forces applied within this unit area of surface is known as stress. Okay, as mentioned in the book here, force applied per unit area is called stress, and stress is produced in a solid by pushing and pulling. Okay, stress is produced in a rock body by pushing or by pulling, and this induces deformation. So because of stress, okay, the rocks are deformed, the shape is changed, and forces acting along the faces of the earth material are shear stresses. So forces acting along the faces of the earth material are called shear stresses. Okay, that means separating forces, and it is this stress that breaks rocks and other earth material. That means because of the shear stresses, rocks and other earth materials are broken. Okay, so we have these. So these are some examples, some types of stresses. Okay, as I told you, this is what we call tensional stress or transtensional forces. That is, the forces are moving away from the common point. So in this case, so here forces are coming together. This is compressional stress. Okay, and so this is what we call shearing stress. So in this case, here it will result in the breaking of the earth material. So let me show you one more diagram. Okay, see here. Here these are the different types of stress. So because of the compressive force or the compressive stress, we have this folding process. Okay, folding is resulted, and if compression is too much, then there may be overthrust fault. Okay, then because of tensional force or stress, there may be stretching of the rock material and the thinning of the rock material, and resulting to faulting process. And another one, third one, is the shearing stress. Because of shearing stress, see, it is the rock body is deformed. Okay, here it may result in the sliding of the rock. That is tectonic shearing. Okay, sliding of the rock body. So these are the important types of stresses. Okay, so because of the stress, different types of stresses, these rock bodies and earth materials are deformed. And shear stresses result in angular displacement or slippage. That you have to remember the diagram. Okay, shear stresses result in the angular displacement or slippage. That the last one. Okay, this one. Besides the gravitational stresses, the earth material becomes subjected to these molecular stresses. That means we have two important major types of stresses. One is the gravitational stress, another one is the molecular stress. Okay, and so we have discussed about the gravitational stresses, that is about compression, then about tension, then about this sliding. Okay, that is shear stresses. So some matter becomes subjected to molecular stresses that may be caused by a number of factors, among which temperature changes, crystallization, and melting are the most common. So molecular stresses result, okay, in the mechanical and the chemical weathering processes. That means molecular stresses are related with the mechanical weathering process and a chemical weathering process. Okay, see here, when there is temperature change, there may be expansion or contraction process, and that is an example of this molecular stress. Okay, see here, in this diagram, see, this is an example of this molecular stress due to temperature change. Okay, see, under the normal temperature, say the molecules may be compact like this, and when it is heated, okay, when the object is heated, then see, there is expansion. Okay, see here, we have this expansion process. Okay, that means molecular subject to molecular stresses. The molecules here are expanded when the temperature is increased. So this is you will mainly find in this mechanical weathering process. Okay, these molecular stresses you will find mainly in these mechanical and chemical weathering processes. And chemical processes normally lead to loosening of bonds between grains, dissolving soluble materials, or cementing materials. Okay, see, another type of this weathering process is this chemical weathering, and the chemical weathering normally lead to the loosening of bonds. Okay, bonds of those elements forming these minerals and the rocks, and sometimes because of the chemical processes, soluble rocks may be dissolved, or because of chemical processes, say some grains of minerals may be compacted. Okay, and thus the basic reason that leads to weathering, then mass movement, and erosion is development of stresses in the body of the earth material. Okay, so it tells the reason for weathering of the rocks, then mass movement of the earth material, and about these erosional processes. So all these are because of stresses, different types of stresses acting on the body of the rocks. Okay, any question from your side, boys and girls? Okay, so let us continue. Remember, stress means force applied per unit area. Okay, and we have two types of stresses. One is the this gravitational stress, another one is the molecular stress. Okay, then temperature and the precipitation are the two important climatic elements that control various processes that I have explained you earlier. When there is a difference in temperature, then there may be difference in the pressure system, and once there is a difference in the pressure system, then wind may blow, and in this way exogenic processes are started, and once there is formation of low pressure, then there may be say rainfall, okay, and there may be this running of the water. So in this way, these actions of the exogenic processes are started on the Earth's surface. All the exogenic geomorphic processes are covered under the term denudation. Okay, so this is the meaning of this word denudation. All the exogenic geomorphic processes are covered under the general term denudation. So all the exogenic geomorphic processes means running water, then rainwater, then glacier, then underground water, wind, sea waves, ocean currents. So all these are examples of exogenic geomorphic processes, and all these processes are covered under the term denudation. Okay, and the word denudation, see, this word denudation is derived from the Latin word denude, okay, which means to strip off or to uncover, to wipe off. Okay, so weathering, mass wasting, or mass movement, then erosion and transportation are included in denudation. So all the processes, okay, weathering process, mass wasting, mass movement, all this will be learning later on. Then erosional process, transportational process are included in the term denudation. And the figure 6.1 also gives, okay, denudational processes and their respective driving forces. Okay, see here, this we have three important denudational processes. See, we have weathering, then mass movement, and we have erosion and transportation. Okay, so these are the three important denudational processes. And the driving force for weathering are gravitational or molecular stress and or chemical actions. So these are the important driving force for weathering: gravitational or molecular stress or chemical actions. Then for the mass movement, the main driving force is the gravitational force, and for the erosion and the transportation processes, kinetic energy. Okay, mechanical energy, kinetic energy is the main driving force. And here when you see this chart, okay, see, we have known that for each weathering process, for each denudational process, we have a unique driving force or energy. Okay, and you must know that the exogenic geomorphic processes vary from region to region. Okay, all these exogenic processes that I have given you example, all these processes vary from one region to another region depending on the type of climate. Okay, see here the density, then type and distribution of vegetation, which largely depend upon precipitation and temperature, also exert influence indirectly on the exogenic geomorphic processes. Okay, then density, okay, then type of this vegetation also largely depend upon the, see, vegetation type is largely dependent on the temperature condition and the amount of rainfall, and these in turn influence the exogenic geomorphic processes. Very simple. Okay, see here, if the mountain surface is covered with very thick vegetation, and we know that thick growth of trees are dependent on the amount of rainfall. If the rainfall amount is very heavy and if the temperature is high, then generally we find this tropical evergreen forest. And once this slope of the mountain is covered with very thick forest, then the action of geomorphic processes will be less. That is the point mentioned here. Okay, if the surface is covered with a thick vegetation, then the action of the geomorphic processes will be less. And for the bare surfaces, okay, the action will be very high. That is the point mentioned here. And within the different climatic regions, okay, within different climatic regions, there may be local variations. Within the same climatic region also, there may be local variation of the effects of different these climatic elements due to altitudinal differences. Okay, so altitude, altitude also affects. See, if this is a very high mountain, and we know that because of the altitude, the top of the mountain may be covered with snow and ice, and here the type of the geomorphic process acting on the surface is different as compared to the low-lying areas. Okay, here the action of the type of geomorphic processes may be running water or rainwater, but on the top of the mountain there may be a glacier as a geomorphic agent. Okay, so that is the point mentioned here. Within the same climatic zone also, there may be variation, local variation in the geomorphic process due to the altitudinal differences, or due to the aspect variation. That means due to the variation on the direction of the slope of the mountain, and variation in the amount of insolation received by the earth, and the south facing slopes are as compared to east and the west facing slopes. Okay, so about this I also have explained in while you were in class 9 also. See here, let us say this is a mountain range. Okay, this is a very low mountain range, and this long mountain range, let us suppose, is running east-west. Okay, running east-west. Say for example, this is the mountain range, and this mountain range is running east-west direction, and it is also in the northern hemisphere, let us suppose. And we know that if a mountain range is running east-west in the northern hemisphere, then generally we find more sunlight, more insolation on the southern slope of the mountain. Okay, see for example, if your house is facing east, okay, then southern side of your house will get more sunshine if your house is in the northern hemisphere as compared to the northern side of your house. So in this way, like your house, if a mountain range is running east-west, then the southern slope of the mountain will get more sunlight. That means the action of the geomorphic process will be more on the southern side of the mountain. There will be more strong wedging process on the southern slope of the mountain as compared to the northern slope of the mountain. So this is an example. Okay, and further, due to differences in the wind velocities, then direction, then amount and the kind of precipitation, then intensity of precipitation, and relation between precipitation and evaporation, then daily range of temperature, and freezing and thawing frequency, then depth of frost, penetration, geomorphic processes vary within the climatic region. So within the same climatic region, okay, because of these differences in the precipitation type, that is, in some areas there may be snowfall, and in some other areas there may be rainfall. This is what I call variation in the precipitation type. Variation in the intensity means in some areas there may be heavy rainfall and there may be less rainfall. In some other areas, that is called variation in the intensity, okay, within a given period of time. Then evaporation rate may be different from place to place. In dry areas, evaporation rate will be very high, and in the wet areas it may be low. Okay, and in some areas the daily range of temperature may be very high. Say daytime temperature may be very high, and at night time may be very low. So we have got a very wide range of temperature. And if there is very wide range of temperature, then expansion and the contraction process of rocks will be very active in that particular area. And likewise, freezing and thawing frequency, that is okay, it will be learning later on. Okay, say for example in a rock, say for example here this is a big rock, and say we have a crack here, and say this crack may be filled up with water, and during the night time this water may turn into ice, and when the water turns into ice, then the volume is expanded. Okay, and because of that the ice will exert a great pressure on the wall of the rock, and this is what we call freezing and thawing. It will be learning, okay, in detail later on. So it means that whatever I have been telling is that due to this variation of these types of precipitation, then amount of precipitation, then intensity, then differences in the temperature condition, then differences in the daily range of temperature. Because of all these variations, there will be variation in the geomorphic processes within the same climatic region. Okay. Up to here, any question from your side? Remember, we have been learning the factors or the causes for the variation in the geomorphic processes from one place to another place. Okay, the factors or the causes for the variations in the exogenic geomorphic processes are learning right now. Any question? Okay, let us continue one more paragraph. So here one very important statement is given here. Climatic factors being equal, the intensity of action of exogenic geomorphic processes depends upon type and the structure of the rocks. So let us consider that climatic factors are equal. Okay, and the intensity of the action of exogenic geomorphic processes depend upon the type of the type and the structure of the rock. Let us suppose the climatic factors being equal, but the intensity of the strength, the intensity of the action of the exogenic geomorphic processes will depend on the type and the structure of the rocks. Now let us read. Okay, what do you mean by structure is given here. Okay, see here, the term structure includes such aspects of rocks as faults, then faults, orientation and inclination of beds, then presence or absence of joints, bedding planes, hardness or softness of constituent minerals, chemical susceptibility of mineral constituents, the permeability or impermeability. Okay, see here the term structure includes different aspects of rocks such as faults that we have learned earlier, then faults also we have learned earlier, then orientation and inclination of beds. So what is a bed? Okay, so let us see one photograph. See here. If you observe this photograph, see here, here this is called a bed. Okay, so this layer has been formed in one particular geologic time. So this layer is known as a bed. Okay, so this layer is known as a bed, BED. And here, so this is one bed and this is another bed. Okay, so in between these two beds we have a boundary, and this boundary is known as bedding plane. Okay, and this bedding plane sometimes may be inclined. Say for example, so this is a bed. This is a bed of this rock formed in a particular geologic time. and below this there may be another bed, and so between these two beds, so we have got a plane surface, and this is known as bedding plane. And this bedding plane may be horizontal like this, or maybe inclined, okay, like this. See, in this case we find these inclined bedding planes. Okay, so see some more photographs. Okay, see here, this is an example of this horizontal bedding plane. So these are beds, and so these are the bedding planes. And one more, okay, and see, this is also another example of horizontal bedding plane. And again, see, this is an inclined one. Okay, here the bedding planes are inclined. And one more, okay, one more is here. This is also another photograph showing inclined bedding planes. Okay, and so this is coming under the term structure of the rock. Then joints, okay, actually joints are the weak lines in the rock. Okay, say for example, this is a rock, and sometimes say you may see lines. Okay, this is not crack. Okay, cracks are opening, but for the joint, just this is a line, okay, a weak line, and if you hit here by a hammer, then the rock will be broken along this line, and so this weak line is known as joint. Okay, joint, joint. Then hardness or the softness of the rocks. Some rocks are hard and some rocks are soft depending on the type. Then chemical susceptibility. Some chemicals are highly susceptible to chemical action, for example limestone. Okay, then permeability and impermeability. Some rocks are permeable, that water can be absorbed, water can be passed through, or some rocks are impermeable, that is water cannot pass through. Okay, water cannot be absorbed. So all these are coming under the term structure of the rocks. So different types of rocks with differences in their structures offer varying resistance to various geometric processes. Different types of rocks with differences in their structure, differences in the hardness or softness, differences in the this angle of inclination of the bedding plane, or differences in the susceptibility to the chemical action, or depending on the permeability or impermeability of the rocks. Okay, we have these various types of geometric processes. We have resistance. Okay, we have resistance to different types of geometric processes. A particular rock may be resistant to one process and non-resistant to another. Okay, a particular rock may be resistant to one process and non-resistant to another. Say for example, limestone. For example, limestone is resistant to wind action. Wind cannot erode a block of limestone, but you know limestone is non-resistant to running water or underground water, because limestone is a highly soluble rock. Okay, especially if the water contains carbon dioxide. If the water is a carbonated water, then the limestone is dissolved very quickly. So in this way, okay, a particular rock may be resistant to one process and non-resistant to another. Just take the example of limestone. Okay, limestone is resistant to wind, but it is not resistant to water because it is soluble. Likewise, metamorphic rocks are relatively harder and more consolidated than other types of rocks, and therefore metamorphic rocks are not easily liable to weathering and erosion process. So these are examples, okay, that a particular rock is resistant to one process but non-resistant to another. And under varying degrees of climatic conditions, particular rocks may exhibit different degrees of resistance to geometric processes and hence they operate at differential rates and give rise to differences in topography. For example, a block of granite. This is a very hard rock, okay, and we may consider two climatic conditions. One may be in the desert. Let us suppose one granite block is in the desert and another granite block is in the other climatic zone. Let's say, for example, in the cold areas. Okay, so in this case, here in the hot desert, the granite block will be expanded during the daytime and contracted during the nighttime, and because of this process, the granite may be breaking down. And in the cool areas, this expansion contraction may not be there. So in this way, okay, because of variation in the climatic condition, okay, the action of these geometric processes may be different, and because of these differences in the geometric processes, we find differences in the landscape on the earth surface. Okay. Any question from your side? Okay, if you don't have questions, then let us stop here for today. Thank you very much for joining my class, and don't forget to send your names in the WhatsApp group for attendance. Thank you very